Welcome back to my YouTube channel Infinite Knowledge, and I am back with another great MATLAB related project in which you can see here we have a microgrid, and we are performing the cyber attack on the microgrid, and how to mitigate the cyber attack over the microgrid. So let's get started without wasting any time. So you are well aware about it. I have already uploaded lots of video related to the microgrid, and you have give enormous support over there. So we have updated that model to the another concern, like a cyber attacks are right now a major concern for all the system, because all the system are now on the integrated with the IoT system, and IoT devices are very vulnerable for the cyber attacks, and how easily the cyber attack can be performed, and to get perform on the cyber attacks over the grid may cause the uh, adverse circumstances by isolating the necessary load, by creating the instability inside the system, and eventually it caused the catastrophic consequences. So how we are going to perform the cyber attack over the system, and how we are going to mitigate it, that all the things we are going to see over this simulation. So you will get this simulation and the related code in the description box. So this is a simulation, and in the simulation you can see we are going to do some different cyber attacks. This is the cyber attacks over the wind. You can see this is the false data injection method, and if the false data injection is detected, that is isolated this breaker, and which finally isolated the wind, which clearly means that if the wind is attacked over the cyber attacks, if wind generator, if the wind controller is on the cyber attack, only that part will be isolated and remaining system remain stable. Then this is the battery attack, like we are going to measure different parameters like a battery management system over the IoT device. But if man in the middle attack or the false data injection is possible over there, if man in the middle attack is performed like this way, like a cyber attack know the IP address of your system, and it detect the IP address and then inject the false data over your system, and you will monitor the wrong data over your SCADA system. So this is also possible. This is also we will check inside the simulation. And once again, this one is also false data injection for the solar system. If the controller is there, and if the false data is feeding at this condition also, the solar will be isolated only, and remaining things will remain stable. So let's get started without wasting any time. So yes, you can see here we have attacked the firewalls also. Firewall detect, like a detect variation is a as function in the MATLAB, which detect the if the input is within the limit or not, or if it continuously changing, or it is randomly changing, and that is detected by this as function, and then it generate the output, and which finally isolate our system. And for that we are going to use this code for the as function detect variation, and this is a code which we have to paste it over this script of the MATLAB simulation, and then we have to save it like a detect variation.m file. Whatever you can check any folder, you can use any folder, just save it and run the model, and don't forget to change the path. If you are getting the notification like a change the path, then use the change the path, and if you run, you will get this type of interface, and this type of interface will indicate that S function block is working completely inside this model. So yes, right now S function code is uploaded, and even it is merged with the MATLAB Simulink to the MATLAB script. Okay. So yes, I have just started the simulation, and you are well aware about this. This system is working satisfactorily. So we are not going to understand the microgrid logic, because you are well aware about it, the how the microgrid is working. And if you are not, lots of video over my YouTube channel I have already uploaded. I will give the description. I will give the link of that video inside the description of this video. So rest asset and no worry about it, just focus on the cyber attack right now, because right now our focus is the cyber attack. So first of all, then we are going to use the SCADA system. So as you are aware about it, this is a man in the middle attack, or this is a DDoS attack that first performed by the attacker. You can see the values is continuously increased, and at particular value, let's say 12, 12 is a node address of our system. So DDoS attack is performed by the hacker. In DDoS attack, it is continuously giving some different IDs, like a 0 to 128, which is similar to your if you have your friend's mobile phone, you are randomly entering different password, and if one password you will get and that password is working perfectly, that open your mobile phone. This is what the DDoS attack actually means, that denial of distribution service, or you can say randomly we are feeding different values and we will check whether we are getting access of that remote system or not, but one particular node address we will get the access. Okay, so this is a node address that we have considered here is a 12. So if you want, you can check at particular 12. When we are getting 12, you will get high output, which means that hacker has right hacker has the access of your system because he had performed the attack, and at particular address the signal is high, which means that hacker has the access of your remote system, and then he will perform the cyber attack. If you turning on this switch, which means that the cyber attack is performed, and as the cyber attack is performed, you will get a random value. Initially we are getting the exact value state of charge of our battery, but right now it is malicious data feeding by the hacker and we are getting random value, and that is detected by this system. Initially this was a green, initially this was a zero, but right now it is detected by the cyber attack, and if you just turning off, it will again detect the cyber attack is isolated and again go back to the normal condition. Okay, but it takes some time. You can see actual value is 80, actual value is 80, actual value of our battery percentage is 80 percentage, but cyber attack performed by the external person and that inject the data which is totally a malicious data and totally wrong data, and this is wrong data that we are getting over our SCADA system, and which clearly means that the so if someone is not aware about that, so it means that the battery is isolated, there is a something abnormal happen in the system, but it is not actually happen, it is predicted, like someone intentionally injected the wrong value over your SCADA system, so you will isolate your system and that eventually cause a production loss. Okay, so this is how the cyber attacks are performed. Again we are performing the cyber attacks, so we are getting random value, and this is detected by the as function. This is the code that is used to detect this variation. Okay, and as the cyber attack is isolated, you will get again the normal condition. But yes, obviously there is it takes some time because it is taking input and checking whether the data is range or not. It wait for some time. If everything is okay, then it is green. So yes, this is the first attack that we have performed for the battery, and finally it isolated the best battery breaker. So this is a breaker which is controlled by this logic, and it isolated the breaker if cyber attack is happen. Okay, again this is the malicious data. So if someone wanted to maliciously changing the value, that is also possible. So right now everything is okay. So if I randomly change this value, then what happen? You can see initially this value remains 0, but if I randomly changing the value, it is changed the from its state from 0 to 1, which clearly means that someone attacked the system and randomly changing the input intentionally. So at this condition also, it is as function detect the variation and isolate the breaker. Okay, so it if it is 1, it means that breaker is isolated and windbreaker is isolated. This is 0. Okay, but if I stop the variation, then the system detect everything is stable and again becomes 0. If this becomes 0, the breaker will again on. Okay, you can see again on. So this is how the system accurately sends the input, sends the false data injection, malicious data injected by a hacker, and this is a firewall. It is a protected device. Okay, and similarly that performance that we are getting at the solar side also, if you are changing the value randomly, you can see if you are changing the value randomly, so it will detect and generate the high output. You can see high is there. Again if I set to the fixed limit, after some time it will become a 0. It means that 1 is cyber attack, 0 is everything is stable. That is what we are just going to perform here. Okay, and all the cyber attacks you will check over here. For the solar also, if the attack is there, then the output, then the battery attack is there, then the output, wind attack is there, then the output. So we have performed all the attack. If you want, you can check. Okay, you can see here, we need to isolate both the things. So you can see here at this stage we have performed the cyber attack. So if you zoom in, you will get to know that this value is not 0. It remain from change its state from 0 to high. And if the cyber attack is isolated at this condition, you can say it is come back to 0. So this is how accurately the system is working. Similarly for the battery also, you can see here at this condition, we have performed the cyber attack, and so it is 0. And at this condition also we have performed the cyber attack, then it is 0. Okay, and if there is no cyber attack, it's remain 1. Similarly for the wind also, at the condition we perform the cyber attack, you can see this is a attack. Okay, I need to swap this data. So at this condition we have performed the cyber attack, so it's changed its state. So yes, this is how it can accurately detect the cyber attack and isolate the system. Okay, so this is how you are going to perform the different type of cyber attack over the microgrid. And even you can detect, or even you can create the firewall inside the simulation, which is definitely help us to isolate the faulty part and make sure all the healthy part remain in the system. And yes, this is if you want this simulation, you will get the simulation and the coding in the description box. If you want any change inside this model, I can change also as per your requirement. Just connect with me through my email ID or through my WhatsApp number that is given in the description box. For any type of MATLAB related project, electronics or electrical related project, you can connect with me. For any type of assignments also, you can connect with me through my email ID or through my WhatsApp number that is given in the description box. Thank you very much for watching this video.